Alright, so second video this week. It's going to be on trig identities. So like I said at the end of the first video, we're actually going to be using this whole page. If you want to jot them down, like I think I also mentioned, on a separate piece of paper or a clean sheet of paper or a note card or whatever, just to kind of have them handy on the side. That might be a smart thing to do. We're going to kind of be using this. And really, I kind of like doing these things. They're almost like puzzles. You know where you get to start. You know what the finish is, right? So if you have a puzzle, you have just a bunch of pieces, and at the end, you know what the picture is supposed to look like. So you need to do everything in between, which ends up becoming your solution. And the only things we get to play with are these things here. All right, we have reciprocal identities, quotient identities, Pythagorean, cofunction, and even odd identities. I could go through explaining things to you, what these all mean, but since we've already kind of discussed these first three in previous videos, cofunction identities, really what those are the kind of the opposite angle in the right triangle. Okay, this pi over 2 minus u really is just saying if I'm in angle A, I'm going to angle B. And do you need to understand the background with those? No, just know that we're going to be using these, and you're going to look for the we're going to be looking for like a pi over 2 minus an x or minus a theta or anything. It doesn't always have to be u. It could be any variable. Same thing with even odd. If you see a negative sign like that, you're going to be looking for that. It should throw up flags. So let's jump into this. So the first thing it's going to say, like, proving identities or verifying the identity. So verify the identity. Let's think. Let's say we have the tangent x times the secant squared x minus tangent of x. Okay, you have to look at these things very carefully. All right, you want to try to think of this as something like a b squared minus a, where a is tangent of x and b is secant of x. So if I had something like this, I could do something to it. I could factor out an a, right? Well, if we're verifying an identity, one thing I have to give you is what's our end goal? Well, our end goal is tangent cubed of x. So you need to somehow turn this whole equation into a tangent cubed. Okay. So again, like I was just hinting at, we have a common tangent of x. So I want to factor out tangent of x. And what I'm left with is secant squared x minus 1. All right, I haven't used any identities yet. I just did algebra. But now, anytime I see something squared, the first thing you want to think about are the Pythagorean identities. So if you did jot down these things here, I'm looking at the Pythagorean identities for something squared. And what I have right now, secant squared x minus 1. But on here, I have 1 plus tangent squared equals secant squared. But I can also rewrite this identity if I subtract 1 from both sides. You can do that with all three of these identities. So if I subtract the 1, I get tangent squared equals secant squared minus 1, which is nice because that makes this whole thing tangent squared. So then I have tangent x times tangent squared I get my tangent cubed. I just verified the identity. So I have this, I turned the left side of the equation into the right side of the equation. That's the way you want to approach all of these. All right. All right. That one was kind of a heavy one. Let's do another one. Let's do cosine squared x plus sine squared x over cosine squared x secant squared x equals 1. So we need to somehow turn the left side of the equation, that fraction, into 1. And your work is the solution. So, this top one, I have squareds, cosine squared plus sine squared. I'm going to default by looking Pythagorean identity. I have cosine squared plus sine squared. Well, that's the same thing as sine squared plus cosine squared. So that top numerator is just 1. So I just have 1 on the top. Now on the bottom, I have cosine squared x secant squared x. Now you could look at a Pythagorean identity right here. However, cosine and secant are reciprocals of each other, right? Because cosine of x is equal to 1 over the secant of x, and the secant of x is equal to 1 over the cosine of x. So if I square them, I just add squares, and we're kind of good. So really what we have is cosine squared of x times 1 over cosine squared of x. So I'm just turning secant squared into 1 over cosine squared. And that's actually, if you do want to use one of these identities, that's using the reciprocal identity right here. So this denominator, you cancel those out, we get 1 over 1, which equals 1, and you're done. Are they always going to be this easy? No way. No way, Jose. Alright, let's try another one. Should it be? So secant squared of x minus 1 times sine squared x minus 1 equals negative sine squared x. So again, our goal is negative sine squared x. But you really don't want to touch that. So you have options here. One option I would highly advise not to do would be to FOIL. It's going to be very messy, and it's not going to help you out in any way. But we got stuff squared, so what you want to look at, Pythagorean identities. All right, so let's take a look at these Pythagorean identities. The first thing I have is secant squared x minus 1. Well, I have a secant squared. Pretty close. We could probably make this into a secant squared x minus 1 just by bringing the 1 over. So if I subtract this 1, I would get tangent squared u equals secant squared u minus 1. Therefore, making this tangent squared of x. And that's using a Pythagorean identity. Sine squared x minus 1. Well, sine squared minus 1. So, ooh, that one's tricky, isn't it? Because look at, if I'm going to rewrite that in my notes for a minute. So right now I have sine squared x plus cosine squared x equals positive 1. That's the Pythagorean identity that we have. But I need to somehow make it into this guy. Sine squared minus 1. Well, if I subtract sine from both sides, I get cosine squared x equals 1 minus sine squared x. And that's really close to what we want. The only problem is that I need a negative one, I have a positive. I need a positive sine squared, and I have a negative sine squared. So what you can do is multiply both sides by -1. And now we have what we need. So this is sine squared minus 1 now. So really, negative cosine squared x is sine squared x minus 1. So this becomes negative cosine squared x. All right, now we're still not anywhere near negative sine squared of x, but we're getting there. Okay, we got to just see what else we have to use. Pythagorean identities I would stay away from now because we've kind of used them, and if we reuse them again, we're just going to work backwards on our problem. And I need to somehow turn a tangent and a cosine into strictly sine. So if I use tangent here, that's not going to do anything for me. Cosine, not going to do anything for me. This tangent, I can rewrite it, and I actually at least get a sine, so that's an option. This tangent's not going to do anything. A cosine's not going to do anything because we don't have that stuff. We don't have negative angles, so we can kind of stay away from the bottom part. So let's try this quotient identity, where tangent u equals sine u over cosine u. So I'm going to switch this to sine squared x over cosine squared x, and the reason it's squared is that's just coming down with the identity because it's tangent squared. But if its tangent is sine over cosine, I can rewrite it as sine squared over cosine squared. All right, looks like we get some stuff to cancel out, and we're just left with, hey, negative sine squared x. We figured it out. We got the other side. There it is. Now, one thing people don't like about doing these things is that there's not just one way to do it. There are easy ways. There are more difficult ways. But there's a bunch of different ways for you to approach these problems. So don't think that if you thought of yours differently than I did, that you did it wrong. As long as the work makes sense, that's all that matters. Okay, because in our next video, what we're going to do next week is use these to solve. Basically, like, you're going to give me the angles, but you're going to have to do this stuff first. All right, so let's do another one of these. Let's do cosine squared. I'm going to switch it up. I'm not going to do x. We're going to do Pokeball now. Okay, so theta minus sine squared theta equals 2 cosine squared theta minus 1. So I need to somehow make these things make sense. Now some people want to do some subtraction, and I get that. Like you see a cosine squared and a cosine squared, and you want to subtract and maybe try to solve. It's okay to an extent. You just don't want to get into that habit of doing it because it's not always going to work. I always try to say turn the left side into the right side. So I don't really want to touch this at all. I want to leave that alone. Right? So we have a cosine squared and a sine squared. I need to somehow just strictly turn both of those into just cosines, and with a minus 1. So I got to look, if I ever have a squared, again, like I said, I always try to look at those Pythagorean identities. And if I have sine squared plus cosine squared equals 1, sine squared plus cosine squared equals 1, I can always rewrite those, right, as sine squared equals 1 minus cosine squared, or I could say cosine squared equals 1 minus sine squared. Right? Those are the same. They're all three of those are the same exact equations. But if I do this and I look at the sine and I replace it with that, with the 1 minus cosine squared, so I get cosine squared theta minus, and now I'm going to do 1 minus cosine squared theta. Go through, distribute that negative sign. So cosine squared theta minus 1 plus cosine squared theta. I'm going to add those two. Hey, never mind, I'm done. That's it. We got what we needed. And we would be finished. Finished. Alright. Now what's going to happen if it's not that nice and you have to get LCDs and all this other crap, because fractions always appear when it comes to math. And that's where everybody always throws their arms up in the air and they do that big oh type of thing. Alright, so now let's do it. Cosecant of beta plus cotangent of beta is going to equal sine of beta over 1 minus cosine beta. Ew, this is like gross. Ow. Alright. Cosecant, there's not much to do with cosecant. Again, we don't have any negative u's or this pi over 2 stuff. So cosecant's really one option, 1 over sine. So I'm going to switch that to 1 over sine beta. Cool. Cotangent. Well, cotangent, let's see what we can do with cotangent. I think we got a few things. We can switch it to 1 over sine. We can do cosine over sine. That's really it. If you switch it to 1 over tangent, I don't know if I said 1 over sine, I probably did, and I'm an idiot. But cotangent, switching it to 1 over tangent is not going to really do anything for us. But we already have a sine in the denominator when we converted cosecant, so we might as well use this other one and switch this to cosine over sine. Right. So now I can combine. So we get 1 plus cosine beta over sine beta. And this is only because, if you look, we have exactly the same denominator. So now this is where we can kind of run into some problems. All right, but we're almost to what we want. This would be one of those problems. If you did things to both sides of the equations, I probably wouldn't be upset. But one thing you can always multiply by, and this is something that I've said in every math class, is this thing called a well-placed 1. You can always multiply something by 1. But what you pick that 1 to be is where you can have the fun. I'm going to multiply the top and bottom of this by 1, but it's really 1 minus cosine. And you're asking me why. I can already hear the where did you get that crap? Well, it's technically that's 1 because it's the same thing around the top and the bottom. But look what I need. I need a 1 minus cosine. And it's also convenient that it's like, not the reciprocal, what is it? The conjugate, I think is what we wanted to look at. So we have that 1 plus cosine, so I'm going to multiply by 1 minus cosine. So now if I was to go through, not necessarily FOIL because it's different to two squares, you get 1 minus cosine squared beta over sine beta, 1 minus cosine beta. So that well-placed 1 is going to help us out. And that's because our numerator, 1 minus cosine squared, is a Pythagorean identity. 1 minus cosine squared would just be sine squared. And this sine cancels out one of the squareds, and we are left with sine of beta over 1 minus cosine beta. And that's what we needed. All right. So that well-placed 1 right there, something that you can always use to your disposal. You can always multiply something by 1. As long as it's useful to you, go for it, you know. That's something I learned I probably senior year in high school, and then throughout college. Multiplying things by 1 can be your best friend. Just make sure it's a fancy one, not just like the legit number 1. All right. So the other way you could have done it, just to point it out, once you got to this point here, where we had 1 plus cosine over sine, you could have cross multiplied with what we had on over here. If you cross multiplied, it probably would have been a little bit easier. But like I said, we try not to touch that right side. But sometimes if you really need to, you do it. You know, you can only do so much. All right, we got like 7 minutes. Let's keep going. Let's do cosecant squared theta over cotangent theta equals cosecant secant. Okay. Now, first thing I want to do, just so you guys understand, this is exactly the same as cosecant times 1 over cotangent. All right, that's not a well-placed 1. That's really just me rewriting this original equation. So a lot of people, like I always said, you usually want to look for a Pythagorean identity because you have something squared. But if you ever have a fraction like this, you can probably take care of that. 1 over cotangent, well, 1 over cotangent is tangent. So now I have cosecant squared, not equals, but cosecant squared times tangent. And that tangent's not squared because cotangent wasn't squared. All right. And now, I need to still somehow get this to be just cosecant and secant. Well, let's think of what we got. Let's think. Well, let's see what cosecant squared is. Cosecant squared 1 plus cotangent squared. Yeah, that's not going to do anything for us. Our goal is to get cosecant secant, and that's just going to make it more confusing. If you're not already confused, I'm sorry if you are. Come to the hangout. I'll explain stuff more. So tangent we can rewrite as sine over cosine. Cosecant we can rewrite as 1 over sine. It has to continue to be squared though. This looks promising. I can cancel out one of these squareds, and I'm left with 1 over sine times 1 over cosine, hey, which is cosecant times secant. And I think we just did it. Hey. Hey. So, could you have done this differently? Totally. You could have jumped in with that that Pythagorean identity, but it does come out to be a little bit messier. But you can. Do we want to do it? I don't know. Do you want to do that one? I can't hear your response. But sure. Let's see. We're gonna do. So this was try 1. And it worked. Let's do try 2. All right. So again, we're dealing with the same problem. I want to somehow use that. But the cosecant squared, that's a Pythagorean identity. That was 1 plus, I think it was cotangent squared. I'm just going to make sure. Cosecant, yeah, 1 plus cotangent. All right. Well, if I have that, and I have one denominator, I can write it as 1 over cotangent plus cotangent squared over cotangent. Do not just cancel that out with one of those squareds. Remember, you have to rewrite it for both. Don't be that person. So now we get, well, 1 over cotangent's tangent. And now we can cancel that out with one of those. So we get tangent plus cotangent, which is still not what we want. But we can rewrite this as sine over cosine. And this would be cosine over sine. Ooh, we're getting there though. We're kind of getting closer. Then we would have to get an LCD. Ugh. So if we get the LCD, we would end up with multiplying this guy by sine over sine, this guy by cosine over cosine. So we would get sine squared plus cosine squared over sine times cosine. Oof. See why I didn't want to do it this way? Sine squared plus cosine squared is really just 1. Hey, here's our answer. So this is really, because 1 over sine is cosecant, 1 over cosine is secant. So that works as well. That's just a whole extra way of doing it. But yeah, that's Pythagorean identity magic right there. I don't know what else to call it. So proven identities, you know your starting point, you know your ending point. You just have to do the work in between. And like I said, not one way to do it. So we kind of covered up a decent amount this week, I feel. Again, if you've had any questions or issues with it, please come to the Hangout and or Meet, whatever the heck we use. I don't know what the heck they're called. Just come and ask questions. If you have questions, we can do a few more examples. All right, guys, if I don't see you, have a great week, and we'll talk to you next week.